Okay, I'm Samuel and I shall prove the volume and the surface area of a prism. So first of all, for volume, we have the base area times the height, and for the surface area, we also have the base area multiplied by the height, but this time we're going to add the diameter also multiplied by the height. So if I was to represent this graphically, we have something like this. This, of course, is a 3D representation, which can be moved to a 2D representation, where we have the bottom part of this circle. We have the main part, which is unraveled to represent a 2D rectangle, and we also have a bottom circle. So to find the volume, we first need to get pi r squared multiplied by the height, because pi r squared, of course, is the area of the circle, and if we multiply by the height, we have unlimited layers of circle, which represents the height of the cylinder or of the prism that you're trying to find. In terms of the surface area, we have 2 pi r squared, but we're also going to add 2 pi r times the height. This, of course, is because we have 2 circles here, which need to be accounted for in the surface area. And then we add the area of this rectangle here, which of course is 2 pi r times the height. So when we add these together, what we get would be something along these lines: 2 pi r squared plus 2 pi r h. And here we have the volume and the surface area.
So today I will be talking about how you can find the surface area of a cone. So let's start with, this is a 2D representation of a cone. Delete this line. And to find the surface area of the cone, well, finding the base area of the cone is pretty simple. It's just a circle, and we know that the surface area of a circle is pi r squared. So now let's find the area of the curved surface. Let's imagine it open up. It will look something like this. And as you can tell, this looks like a piece of pizza, which means that it is a sector of a circle. So what do we do when we're working with a sector of a circle? Let's label this angle theta first. And then this length will be equal to the height of, the length of the cone. So let's label it L. And the arc length of this sector would be equal to the circumference of the base, which we know is 2 pi r. So let's do some maths. The arc length we know equals to pi over 360, theta over 360 times 2 pi L. And since the arc length is also equivalent to the circumference of the base, we can deduce that theta over 360 times 2 pi L equals to 2 pi r. And hence we can deduce that r equals to theta over 360 L. And then the sector area, which would be theta over 360 times pi L square, which will equal to theta over 360 times L times pi L. And as we know, the R is equal to theta over 360 times L, which is this thing. And then we can simplify to, so sector area equals to R pi L. And we know that the area of the base is pi r squared. So the total surface area of a cone is equal to r pi l squared, which would equal to pi r
Okay, so now I'm gonna try and prove the volume of a pyramid and use that to extend it to prove the volume of a cone. So we can start by considering any pyramid. So I'll draw one here. I'm just using a square pyramid now, but really it can be any type of pyramid. So we'll say that this pyramid will have height h and it will have a base area of A. So now what we can do is we can try and approximate its volume by splitting it into n layers, with each one larger than the next. So if I draw it out, since I'm using a square-based pyramid, if I split it into n layers, then it would approximately look like a stack of multiple cuboids, each one larger than the next. So now if we take a look at each individual cuboid, we can see that the height of each prism is h over n, since the initial height is h and we're dividing it into n slices. And then because this is a pyramid and the shape of each base is smaller than the next, but they're all similar to each other, so we can see that the dimensions of each layer, so if we compare so let's say we choose any layer K, and if we choose that layer, then the dimensions of the base of the K layer will be K over N compared to the lowest base. So for example, let's say this is the K layer, then the dimensions of that layer will be K over N as a ratio, and then therefore by the area ratio, the base area will have of the kth layer will be K over N squared times A, which is the base area of the lowest layer. Now, so we can approximate its volume now by combining so now we have the volume of each layer of the step pyramid. We can go and approximate the volume of the entire pyramid by factorizing it. So the height of the first layer would be h over n, and its base area would be 1 over n squared a. And the second layer would be also of a height of h over n, but now its base area would be 2 over n squared a. And we can continue like that until we get to the last layer, which is h over n and n over n squared a. So now if we can first factorize this by removing the by removing all the terms that are the same, and we will be able to take ah over n cubed out of the entire expression, and what's left will be the sum of cubes, which is 1 squared plus 2 squared plus 3 squared, and then we can add that all the way till n squared. And now, so we have a proven expression already, which is the sum of consecutive cubes when factorized would be n plus 1 to n plus 1 over 6. So now we can take a look at this expression, and if we expand the top bit, then we will get this, which is 2n squared plus 3n plus 1 divided by n squared, divided by 6. And then if we take this over here, we will get wait, let's rewind a bit. So if we cancel out this term and this term, we will get n squared. And then if we swap the n squared over to the next fraction, if we swap 6 over, we'll get ah over 6 and n plus 1 to n plus 1 over n squared. So now if we take a look at the fraction on the right, and if we simplify it, we get this expression, which is 2n squared plus 3n plus 1 over n squared. And simplifying that furthermore will give us AH over 6, and this would be 2 plus 3 over n plus 1 over n squared. Now, if we take a look back at the front, we split it into a lot of levels to try and approximate its volume, and if we want to get as accurate as possible, we would make sure that it will be split into infinite amount of layers. So as the value of this expression approaches infinity, and which are right here, we see that for the last two terms, 3 over n and 1 over n squared, as n gets bigger and bigger, the value will become closer and closer to 0, so it would eventually become a over 6 times 2. And so if we simplify that, we would get 1 over 3 times a, which is the base area, times h, which is the height of the pyramid. And so that would approximate the volume of the pyramid here. And so since we never specified what the shape of the base would be, we can extend that to work out the volume of a cone using the same principle. So if this was a cone with the height h and the radius r, then by using this formula, we would get 1 over 3 ah, and we know that the area of the circle is pi r squared, so the formula for the volume of the cone would be 1 over 3 pi r squared h.
Mr. VJ, we are going to prove up the volume of a sphere, and so according to Cavalieri principle, for two solids of equal height, if the area of the cross section of the two solids at different levels, at every level is equal, they have the same volume. And so we are into these two diagrams, which one is a hemisphere and with radius r as shown here, and also the height of h, as we supposed the height is h and it does not have a real value. And the second diagram on the right is a cylinder with a cone inserted inside the cylinder, and the height of this part is also h, as supposed by me, and also the height of the cone is r, and so the height of cone is r as shown here, and therefore as I suppose this cross section of the hemisphere to be a here, and therefore by the Pythagoras theorem, as we all know, is a squared plus h squared equals r squared, and therefore a is equal to r squared minus the root of r squared minus h squared. And we leave this for a bit here, for a while here, and to the next side, on the right side, the area of the we need to find the cross section of here of the solid to make it equal to this cross section here, so that we can prove that the volume is the same. And the large circle outside the large circle of the cylinder represents has a radius of r, and if we draw a vertical cross section of the plane of the solid here, there will be it will look like this with similar triangles, and here is radius r, and here we suppose here is the radius h, and here is the radius r, and by similar triangles we can figure out that this is 2r and this is 2h, and this is 2h, and by subtracting the area of these two circles, we can get this formula. Here, which is the area of here also, pi r squared, but which r is equal to a, and a is equal to this, so that pi is for this is the equation of the cross section of the hemisphere as shown above, and as shown here it's also equal to the cross section of on the right. And moving on to the next step of the proof. Sorry, I need to delete the previous stuff by my classmates. And this is the other proof, which and the proof here is that the volume of these two are equal, and volume of the sphere is equal. Volume of the hemisphere. Sorry. Hemisphere is equal to the volume of the prism or cylinder minus the volume of the cone inserted inside. Let me delete all the things here. Sorry. And therefore it as shown here, the volume of the prism is by the definition shown by previous classmate is here, and minus the volume of cone pi r it's and by the previous theory above, we can conclude that R is equal to H here in the here, and this leads us to this. Leads us to this. Yes, it's correct. And therefore the volume of a sphere, and because the hemisphere is half of a circle and the volume of a sphere is 2 times this amount, and therefore we can conclude that the volume of the sphere is, yes, this is the end.
So good morning, and today I'm going to talk about the surface area of the sphere. And so as you can see here, I drew a sphere and I divide it into n amount of pyramids. And if I put one out, it's the red pyramid here, and the height of the pyramid is r. So according to Brian's proof, pyramid's formula, the area of pyramid's formula, it's equals to 1/3 base area times height. So in this case, as the height is r, so we can turn it into 1/3 base area r. And as you can see, the base area of the pyramid here is one box, which the n amount of pyramid's base area will be the surface area of the sphere. So, according to Jedediah's proof, the volume of the area of the sphere is 4/3 pi r cubed, which is equals to 1/3 n amount of base area times r, which will lead to the surface area of a sphere here. So if we solve this equation, it will be equals to the surface area will be equals to 4 pi r squared, which is the surface area which is the equation of the surface area. Thank you.